All right, this video is going to be about trigonometric substitutions. I am going to split this series into two parts, one with looking at just when we do a sine substitution, and then one where we're doing tangent and secant. On an exam, I would give you the hint shortcut. It's at the beginning of the notes that's from our textbook. So if you are in my course, then know that that's what you are going to be getting. But here is kind of the problem solving strategy that we are going to be looking at. So if you have inside a radical a squared minus x squared, it might be that you actually just have arc sine, or that you're able to do a u sub, and doing this trigonometric substitution is not the best thing because it can be a little bit cumbersome in order to do this and make sure you have all the right parts. However, if this is one like we're going to be doing in the examples, you're going to be making a substitution where you're going to say, let x equal a times sine theta. And if you look down here at our little diagram here, if we're going to set up this right triangle where x is across, a is here, so sine of theta is x over a. And then our opposite side is a squared minus x squared. Okay, now notice that cosine of that theta angle would then be that square root side over a. And so this substitution is actually going to give us a cosine theta, and then we'll be able to do some integration from there. You are going to have to put this back into x, so make sure that you use some arc trig in order to do that. Again, we're going to do some examples here together. All right, so the first example that I have for us is to evaluate this integral. First thing you should look for is a u sub. I do not have an x dx on the outside. I cannot use u substitution. So because I see that this would be an a squared minus x squared situation inside the square root with a equal to 3 to get 9, then I know my substitution that I need to do is 3 sine theta. Well, I also have to plug in for dx, right? So I need to plug in 3 cosine theta in for my dx, d theta. All right, let's go ahead and do that substitution here. So that's going to be the integral of 9 minus x squared is 9 sine squared theta. And then in place of dx, I do 3 cosine theta d theta. I can factor out a 9 here, and I'm left with 1 minus sine squared on the inside of that radical. Well, 1 minus sine squared is cosine squared. And so this radical, once I take the square root of that piece, I'm going to have 3 cosine theta. And if you notice back up here in the notes, that's what we should get when we do that substitution. That's what we should end up getting on the outside, okay, when we take the square root and do that trig sub with the Pythagorean identity. All right. So I'm noticing that this is 9. I'm going to take that on the outside. Cosine squared theta d theta. We then have to use what we did in trigonometric substitution in order to get this into an integral that we know how to do. So I'm going to do another trig substitution here. Cosine squared theta, we're going to go ahead and substitute with 1/2 plus 1/2 cosine 2 theta d theta. And I can integrate that. I end up getting, I'm going to take the 9 actually on the inside as I do this, 9/2 theta plus 9, okay. I have a 2 here on the inside, so if I take the antiderivative, I need a 1/2, so 9/4 sine 2 theta plus c. Now, sine 2 theta is 2 sine theta cosine theta. So this ends up being 9/2 here, where sine theta is going to be x over 3. Let's see, what's cosine theta if I have this all here? Okay, so this is theta, this is x, this is 3. So cosine is going to be cosine of theta is going to be square root of 9x squared over 3. So I'm going to do that substitution in here. And then theta is arc sine of x over 3. So I have 9/2 arc sine of x over 3 plus 9/2. I'm going to pull this out here. Okay, so 9/2. I'm going to run out of writing room, but that's okay. Okay, sine of theta is x over 3. Cosine of theta is square root of 9 minus x squared over 3 plus c. So this is going to require you to know all of your trig from pre-cal and use it here. Those of you that also took me for pre-cal, this is why I liked using representative triangles for you for your sines and cosines so that you can go through and figure out all your pieces of your triangle in order to do this plug-in here. Okay, so been planting that seed for a little bit so that you can reason through these. Let's do another example. See how this is going to go. Okay, so again, the first thing I should look for, I have an x squared inside a square root. I don't have an x on the outside. That's a problem, okay? Since I have something of the form a squared minus x squared, where a would be equal to 2, then I'm going to make the substitution x equals 2 sine theta, and dx equals 2 cosine theta, d theta. And we know we're going to probably need this eventually, so let's go ahead and draw this all out. So if the sine of theta equals x over 2, that's how we're setting this up, then this side right here ends up being 4 minus x squared. All right, let's go ahead and do our substitution here. So square root of 4 minus 4 sine squared theta all over 2 sine theta, and then in place of dx, 2 cosine theta, d theta. These 2's cancel. I'm left with 4, if I take that out, square root, 1 minus sine squared gets me cosine theta. So let's go ahead and combine the top. So I get 2 cosine squared over sine, and then d theta. Now, it would be really nice if there was a sign up in the numerator because then I could use u sub, but it's not. It's in the denominator. So I'm going to have to use a little bit of a trick again with some trig in order to get this to be simplified. So I'm going to redo or substitute in, I should say, 1 minus sine squared for cosine squared. And the reason I know to do that is because then I end up having sine and sine here in the top and the bottom, and I might be able to kind of manipulate that a little bit. So let's see what happens when we do that. I'm going to go ahead and take the 2 out just because it's in the way right now. I'm going to end up with 1 minus sine squared over sine. And that's going to end up giving me 1 over sine is cosecant theta. And then sine squared over sine is just 1 sine. Now you might need to look up what the integral or the antiderivative of just cosecant is. Off the top of my head, I probably would have to look this up. So again, on a test, I would give you some of these that are a little bit weird, a little bit different. But that's going to end up being the natural log of cosecant theta minus cotangent theta. And then the antiderivative of negative sine gives me plus 2 cosine theta plus c. All right, let's go back up to our triangle and think about what cosecant, cotangent, and then cosine I do know is going to involve this. So let's go up here. Okay, cosine theta is going to be root 4 minus x over 2. So I do have a 2 cosine theta that I need to plug in for, so that's one of my terms. All right, let's figure out what is cosecant of theta. Cosecant of theta is 1 over sine, so that's going to be cosecant of theta is going to be 2 over x. And then let's think about what cotangent would be. So tangent would be x over the square root. Cotangent would be the square root, or adjacent, excuse me, over opposite. And so that's going to go down here. And that is our full answer, friends, for that integral.